Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
Let's talk a little bit about ocean temperature and storm intensity. Okay. This really comes into play when we start looking at our tropical storms. Okay. What causes those tropical storms? Well, it has to do with the surface of the ocean. Okay. If the surface of the ocean is cool versus if the surface of the ocean is warm. Okay. As the air rises in a tropical storm, we'll come back to this guy in just a moment. As the air rises in a tropical storm, one of the features that really keeps this going is the humidity. Okay? If we have humidity, then that's going to lead to condensation. Right, so we're going to have lift. Usually it's going to be convectional lift in the equatorial regions. It gets warm, the air rises. Good, humidity rises, the air rises, it cools, so we get condensation. That condensation releases latent heat. Okay, that release of latent heat through this phase change of water, through condensation, is going to cause additional lift. Okay, what feeds this additional? It's this additional lift. It's being over humid water surface that we get this additional lift. Okay, so let's take a look back at this now. Okay? If we're over cool water, like California for the most part, if the air is cool, or if the water, the ocean temperature is cool, then the amount of evaporation is going to be giving us some water vapor. Some water vapor above the surface. You go to the ocean, it isn't like bone dry there. It's going to certainly have some. However, if we go over to the Gulf of Mexico, then we're going to have warm water. Warm water, the molecules are more excited already, right? They're closer to this process of evaporation. Okay? And so what we're going to start to see is if we could measure the amount of humidity, or if we did measure the amount of humidity there, it's going to be increased. Okay, this is on a scale. And so if we were to look at this between cold water and warm water, it's on a scale. The warmer the water, the more amount of water vapor we have. Warmer the water equals more vapor. Okay, so what? Okay, well, it's that water vapor, it's that humidity that leads to the condensation, which leads to the release of latent heat, which causes additional lift. All right, so warm water, Gulf of Mexico. Why do they have hurricanes over there and we don't have hurricanes in California? It's right here. It's this. Okay? It's because of that warm water. When that warm water begins to lift, when the air over the warm water, the air that has more water vapor, higher humidity, starts to rise, we get condensation. Okay, will we get condensation over here? We get a lifting. Okay, but we get more latent heat. And if we do that, all right, then we're going to have more lift. If we get more lift, then we're going to be seeing greater intensity, more intense storms. Okay, this we know, okay? Whether we like it or not, whether we think climate science is a bunch of malarkey, there is a reason that we don't get hurricanes over here in California, and we do get hurricanes over in the Gulf of Mexico. It has to do with the amount of humidity that is there, and that amount of humidity is dependent on our water temperature. Okay, now, let's say that we go a little bit further. What happens if we continue to increase our ocean temperatures? Okay, so we're cold, we're warm, and now what happens if we get even warmer? I don't know what color. I always use red, so we can't use green. That would show good. Even warmer. Okay, currently what we're looking at is in not so many years we've gone up. I think they said the Gulf of Mexico is 1 degree Celsius warmer than what we saw. I don't remember how far back it went. Okay. We're starting to see warmer temperatures, especially in our tropics. Okay. Let's say that we have that, and let's say that this air is maybe a little bit warmer as well. Air warmer. Okay, warm air can hold even more water vapor. So now when we draw our little water vapor, it's going to be even more humid. The specific humidity is going to be even higher because we've got even more evaporation coming off of this even warmer water. And the air is perhaps going to be a little bit warmer. That means that we've got even greater holding capacity. Oh no. And it starts to rise. And so we get condensation. And then we get a huge release of latent heat. Oh, it's going to get bad because then with this huge, then it's going to be more strength. Okay, it's going to be even warmer, and so it's going to pull up even more, and it's going to be pulling in even more from other areas, and it's going to be causing the intensity of that storm to get more and more and more. Okay, so it goes back to this very basic principle: humidity, air rising, condensation, release of latent heat energy. But in the tropics, that matters, right? That's what feeds those tropical storms. Okay. But if we increase the temperature of our water, we're going to be seeing more and more and more of these very high strength storms. Okay. When these storms do go over land, you'll notice that they don't have any humidity underneath them at all, and so they really start to disperse. Okay. Ian was a recent storm coming up through the Gulf of Mexico, warmer waters, huge strength. I think it was category 4. That had to do with the wind speed that it was blowing at, but also that's going to relate to the size of the sucker. And it goes over Florida, gets a little bit weaker, but then it gets out over the Atlantic and comes back in again. It really has a lot to do with that temperature of the water on the intensity of these storms.